So this is going to be a hands-on workshop. I do want to start out with just a little introduction about DynamoDB, how we think about modeling with DynamoDB, why we use DynamoDB for certain use cases, and how it fits into some common serverless architectures. Then I'll hand it over to Alex, who's going to lead the hands-on segment. So, why do we have databases? Obviously, we need some kind of durable or a persistent state for our applications. Most of our applications are going to need that. Our application or compute layer is typically going to be stateless in a cloud-based environment. It gives us a lot of flexibility, and we want to centralize that stored information. So we have a number of properties here that are important typically. The first would be atomicity, which means that when we make a change to a record, say we're changing two different values, two different columns, we want that to be fully committed or not at all. We don't want to have a partially applied change to our data to be visible to our application. Excuse me. We want consistency. So if we write a change or specifically read after write consistency, if we write a change to some data and then we read it back again right away, we want to see the data inclusive of all of the changes that have been made to that. So, and the other thing that you want to be able to do is to say, I want to place conditions on my change requests. So you might say, I want to increase this balance in a online checking account, but only if the checking account exists, for example. So they have to be enforced correctly, and that's something that a database can provide for us. We need isolation also. If you have multiple application threads, multiple users, all working on the same data, you want to be sure that there's no conflicts, one change at a time, and predictable final state. And then durability. When you store this data, it's important, maybe important for your business. You don't want to lose any of the changes that you've made in the event of something like a power loss or failure of a hardware component. So one thing that is important to note about DynamoDB is that it satisfies all of these at a single item or row level. These are the ACID properties that are most commonly associated with relational databases for online transaction processing types of use cases. Some NoSQL databases make different choices around these properties. They're designed for a different set of trade-offs, and they're not described as being ACID compliant. They're instead basically available, excuse me, soft state or eventually consistent or base. Some people who are unfamiliar with DynamoDB assume that it's not an ACID database, that it follows the base pattern of some other NoSQL databases they've heard of. The original Dynamo service that was developed in Amazon's early days and shared through a really interesting white paper was actually base. But DynamoDB is ACID. It has all of these properties. Sometimes you'll hear people who come from a relational database background claiming that DynamoDB is NoSQL and so it can't be consistent. You can rest assured that DynamoDB does provide all of the properties shown here. In fact, DynamoDB also supports powerful distributed transactions, providing atomicity and isolation for multi-item reads and writes. So let's talk about how DynamoDB structures data and indexes across it so that we can retrieve things very efficiently. The highest level of abstraction is a DynamoDB table, much like a typical database that you might be familiar with. It's a little bit different though, because it's interesting to think about DynamoDB table almost like a big bucket of data. And it's not necessarily the same thing as a database that you might be familiar with that has many tables. Within our DynamoDB table, we have items, which or rows. And in those items, we have attributes that are a lot like columns. So one thing you'll see right away in this diagram is that not all of the items have the same set of attributes. And that's because DynamoDB has schema flexibility. We don't enforce, that every item in every row has to have the same structure. Every item in every row does need to have a partition key, and optionally a sort key. So these are two attributes or two columns that you can add for your table or configure for your table, and together they make up what we call a primary key, and it uniquely identifies each of these records in the table. So you'll hear DynamoDB described as a key value database, and really this is where it comes from. Every item in the table has to be uniquely identified by this primary key so that when you want to retrieve that item, you can make a request and say, I want this item, and DynamoDB will serve that back to you. So the partition key is used essentially to model one-to-one relationships. It's that most basic of have key, get value type of pattern. It allows us also, because DynamoDB does some very powerful horizontal scaling that I'll talk about in just a moment. It allows us to distribute the traffic and the load across the various components of the service on the back end, and allows us to scale that out. It also allows us to identify a collection, and I'll talk about a collection in just a moment. The sort key, if you have it. Sorry, was that Alex? Did you have something?
Nie, no, prąd mi wrócił bardzo późno, także luzik, śmiesznie było.
Sorry, I wasn't able to get that, but okay. So the sort key allows us to model for one-to-many relationships. It allows us to collect related items. So if you can think about this, it's like these item collections actually are built around having the same value of partition key.
No, a więc myślę,
but unique value of sort key, and allows us to do some very efficient filtering and sorting of that data. We can then retrieve items from that item collection using conditions on that sort key value. It's a very powerful way to add this filtering. We can say how many of those items we want. We can get them back in forward or reverse sorted order, and we can just retrieve the number that would match that pattern. This is important to note when we talk about DynamoDB being key value. We can also use a sort key, which adds a lot of power, and we're going to use a fairly simple pattern for the workshop today, but most of the power in DynamoDB and advanced data modeling comes from using these sort keys and building item collections. I want to talk just briefly about how we do that horizontal scaling with DynamoDB. We essentially ask you, using that primary key, we build a hash of those values. So for example, here in this table with customer orders, our primary key is the order ID, and that must be unique. So what we're going to do with DynamoDB is that we have a deterministic hash that we use to distribute across a number of different partitions on the back end of the service. So what we can do with this is that we automatically add partitions and scale things out for you based on your load and the volume of the data that you're working with. There's another concept that's called normalization, and in the early days of relational databases, it represented an approach to modeling your data and reducing your data duplication. Due to the high cost of durable storage at that time, reducing the overall data volume was a really high priority. If we look at the example data shown, we can imagine it might be a retail sales application. There's a table which stores orders, another stores information about the customers, and a third stores merchandise details. So looking at the orders table, we can see that customer 100 made 2 orders, but we don't record customer 100's details twice. We can reference that information from the customer 100 record in the customers table. Same is true for product 300. It was part of 2 different orders, but we only record the product details once, referenced by product 300 in the products table. So you can see how this reduces data duplication, but it comes at the cost of something called a join. A typical SQL database with normalized data structure depends on CPU to go and get the various entries from the tables and to build a complete result for the application. In DynamoDB, we tend to denormalize because there is schema flexibility and no engine in the compute to go construct the result for us via a join when requested. We store the result exactly as we want to read it later. This is an important part of DynamoDB's scalability and consistent performance at any scale. Now, I want to highlight that very powerful functionality I mentioned, item collections. Remember that we mentioned a table that has a composite primary key, so having a partition key and a sort key. It allows us to build a collection of items. The set of items with unique primary keys but the same value of partition key is an item collection. It allows us to narrow our queries by saying, Look in the item collection that's identified by this particular value of partition key and fetch me a filtered and sorted set of the items based on the parameters that I provide. It's very easy to imagine a model that would use something like an IoT device ID as the partition key and the timestamp of a periodic sensor reading as the sort key, the reading itself recorded as an additional attribute or column. Now we can do time-sorted range queries for a given device. It's pretty powerful. The sort ordering is not always important. What's most important is that an item collection allows you to logically group a set of items. They're related by the partition key value. All right, now let's recall that DynamoDB has that schema flexibility. It means that items with different sets of attributes, different schema, can coexist in the same table. They might be different entity types. In fact, they can also be related by an item collection. And that item collection can be in the base table or the primary index, or we can build it in a secondary index. Okay, so now hold on to your relational database hats because I'm going to suggest that when you query a DynamoDB item collection containing multiple types of entities, it's a lot like a join. It relates records of multiple entity types, and you get some very neat sorting and filtering capabilities too. This join is powered by highly scalable storage, and the performance is very predictable. One way to think about this is to consider DynamoDB as having two types of record, items and item collections. Item collections allow you to efficiently change small parts of the overall record or to efficiently retrieve selective parts of the record. Optimistic concurrency control is a standard approach to concurrency control in NoSQL databases like DynamoDB. I can give you an example here. Essentially what you're doing is it's a read and then conditionally write type of pattern. If we had a shopping cart, for example, what we're going to do is we're going to retrieve the version of the cart that we believe is current, and we'll have an attribute or a column that stores the version. Then we might make some changes. We might be adding some things into our shopping cart, and we're going to go back to that cart record and try to write to it. But we're going to place a condition expression on that write that says the version must be what I expect it to be. I want it to still be the same version that I read most recently. If that version number has changed, then don't write this update to the record. In fact, what you would do then most likely within your application would be to go back, retrieve the latest view of the cart because you know that something else has changed. Some other thread has updated the cart since you first looked at it. So this is how we get isolation and how we guarantee consistency in many cases with DynamoDB. I want to talk just really quickly about some basic flow modeling steps, and I think this is probably very familiar to Alex. With DynamoDB, we're going to think about how we want to store and retrieve our data and index it or store it exactly as we want to retrieve it to serve our most common access patterns. So the standard approach here would be to start by creating an entity relationship diagram, just as we would with a relational database, so that we understand what is the data in our store, how does it relate to each other, and how are we going to structure that. We're going to make a list of our actual access patterns. And one way to think about this is, this is an application where this is a transactional or an interactive type of an application. And we're probably going to build a bunch of APIs or a bunch of functions within our application code. Each of those is going to have a particular access pattern. So we know what they are. I mean, these are things that we're going to be calling many times the same way, so we can structure the data to match. So once we have a list of access patterns, we can define primary keys for the items and think about the relationships. Where do we need to have strong consistency and where do we want to have guarantees of uniqueness in that primary key? Then we can add secondary indexes to support any other remaining patterns. And with DynamoDB data modeling, it's often an iterative approach. You start by working through these steps. You go back and you review and you say, well, actually, I missed an access pattern. I need to go back and cover that and adjust. One tool that we have that makes this a lot easier is called NoSQL Workbench for DynamoDB. It's available for download from AWS. It allows you to kind of think about this model and develop it iteratively. It allows you to insert example records and then see what they look like from the viewpoint of multiple different indexes. So I highly recommend taking a look at this tool. It's very, very helpful when you're developing a data model. So how many tables? You may have heard a lot of discussion about a single table design with DynamoDB. And we can see in the diagram here, Plato says that there should be one table, and Aristotle actually wants 5. So what should your philosophy be? I want to start by reviewing, why are we using DynamoDB? We want to go get what we want from the database quickly and efficiently, and we need to satisfy our operational requirements simply and effectively. So if the data is directly related and makes sense as a single record, denormalize it, make it one record. And that automatically makes things atomic because it's a single record. If the data is directly related, not by denormalization, but by an item collection, then it must be stored in the same table. So I think the most important things to remember in DynamoDB is that schema flexibility and item collections, and take advantage of those when you can. Sometimes the number of tables you're going to need to best satisfy a particular application or use case is going to be more than one. You may have 5 tables, and that's okay. Single table design does not really mean that if you wind up with multiple tables, you've messed up. Sometimes it's, you have subsets of your data that maybe don't need a sort key. Maybe you want to have the data type for the primary key be a number instead of a string. Or maybe you want to have different settings for that particular set of items, that data. Maybe you want different backup settings and different table classes for storage. So try to denormalize, let DynamoDB item collections and indexes do all of that work for you. And avoid starting with a traditional relational mindset where you have a table for each type of data, because that's not going to give you the opportunity to benefit from the unique strengths of DynamoDB. Why do we want to have serverless with DynamoDB? Well, there's no servers to manage, right? There's no maintenance or planning around that. There's no engine version, for example, that you have to think about upgrades in. And that means lower risk. It also means you don't have to do any capacity planning. It's very much easier to manage. It gives you time back to actually work on things that make a difference for your users. It can reduce costs also. There's less operational support, less time spent, and it's easy to scale up and down exactly as you need to, right? You're not going to be over provisioned. You can move faster and make a bigger impact for your customers. Quick discussion about serverless architectures. We can see Lambda here is going to make some kind of direct data operations against our database, our table. DynamoDB has changed data capture called DynamoDB Streams that allows you to see events for every single mutation that you make on your table. You can then trigger Lambda functions based on that stream of events and take actions based on that. One of them, and we'll see this actually in the workshop, is to go back and kind of aggregate some of the records from or events from the stream, and then record an aggregated result back in DynamoDB. We could also take that event data and persist it in a different store, something like Elasticsearch, if we wanted to be able to make full text or fuzzy text queries across it. We could then write those records into Kinesis Firehose or notify of change through SNS. And then Firehose, of course, could aggregate that data, write it into S3, maybe in Parquet format, and then we can query it with Athena, which is another serverless service within AWS. So there's a lot of power that we can build around serverless architectures, a lot of different options. Today in the workshops, we'll see 2. We'll see Lambda making direct data operations against DynamoDB, and then we'll see a triggered Lambda function, which is doing that near real-time aggregation for us. And that's all I have. I think we can move on to the hands-on workshop now. There are a couple of links here, the link to go and check out Nosql Workbench and some other labs. And if you do want to follow us on Twitter, we have the DynamoDB handle there. Please give us feedback or ask questions. We have folks that are following that handle that are happy to help. Alex, are we ready for the hands-on workshop?
Pete, I think we are. Thank you for the slides. Those were great. I love the Plato and Aristotle picture for sure, but also that note about item collections. You know, you were the first person to introduce me to that concept, and it's such a powerful concept in DynamoDB, thinking about not just individual items, sometimes denormalizing onto that item, but also creating collections of items that share the same partition key, allow you to fetch them in a single efficient query request. So that was a big game changer for me when you introduced that to me. So I love it.
I think, you know, what we see a lot is people just bring that relational mindset and they just automatically start, you know, normalizing and breaking things out into lots of tables. And what ends up happening with DynamoDB that way is you make lots of different requests. And ideally, we'd like to structure it so you can make one single API call and get back exactly what you want, right?
Yeah. Exactly. Love it. Cool. Love all that interaction too with DynamoDB and serverless. And honestly, serverless applications, that's how I got introduced to DynamoDB. You know, I was working for Serverless Inc. We're teaching people how to use serverless applications, and Dynamo just fits so much better with the compute and sort of model of Lambda of serverless applications as compared to relational database, whether that's not requiring a VPC, not having connection limits where you have all these little Lambda functions spinning up and connecting to your database, scaling really well. So that's how I got introduced to Dynamo, and I think it really is the perfect database for serverless applications. So excited to jump into some of that here.
Awesome.
Cool. So I will take over here. I'm going to, first of all, I'm going to share a couple links in the chat, and I'll walk through each of those links just really quickly what they're going to mean for you as folks. So I just shared in the chat 3 separate links. I'm going to share my screen as well. So I assume you can see my screen. I shared 3 links. The first one is just some workshop setup type stuff. How do you get your machine ready to actually do this workshop that we're going to be doing here? You know, you need to install the AWS SAM CLI. It works on Windows, Mac, Linux, whatever you want. So there's instructions there for all that if you want to get that set up. Number 2, you need to configure AWS credentials so they're available on your machine so that the AWS SAM CLI can pick those up and to perform a deploy. You know, if you have your own account, that would be great. We recommend you just use that. You know, all this workshop stuff will fit under the free tier, so you shouldn't have to worry about any costs there. If you don't have an AWS provided account, we do have some AWS provided accounts for you that you can go sign up for. So if you see there's a link there, visit this website to retrieve your credentials. You can log into that, get yourself provisioned an account that allows you to create these resources. That account is going to be good for the next 12 hours. So, you know, even if you don't get everything done within this workshop, that's okay. You can still keep working on it after the fact. It will get torn down after 12 hours there. After you configure those AWS credentials, you know, you want to install Node Js and Npm, and then also clone the GitHub repository. That's another link I have in there. So I just want to show you the Git repository we have here. This is the Lambda DynamoDB workshop. That link is in the chat there as well. You can see if you're on the main branch, it has everything you need. So it's going to have your completed SAM template. It's going to have all your function code, all that stuff. But it's also chunked into different steps as you walk through this thing. And you can look at different branches as you work through these different steps. So if you want to switch the branches here, you click main. You'll see all the different branches here. So, you know, module 1, part 1, you can click on that. Now we have a lot fewer things. All we have is, we don't even have our SAM template. We have a little bit of source code, but it's just one simple file for that. And then you can switch to, you know, 1.2, which is going to have your SAM template, a bunch of other stuff there. So what those branches do is they incrementally build on each other. So as you're working through the workshop, you can see that in GitHub. My recommendation, if you want to be following along live and actually deploying this as we're deploying this, is to use the GitHub repository, clone that down, and just use those branches and switch to those branches and deploy from there rather than typing it all out into your thing. I think it'll be easier for you to keep up there. So check out that workshop. The last link I have that I sent in is just a written step-by-step guide to what's going on here. You can also see that linked in the GitHub repository there. So if you click on that workshop guide, Here we go. We got a 42-page guide for you. So we're going through all this stuff in deep detail. We're covering the concepts, the code you need to write, the commands you need to run, and how you test it and understand and make sure what's happening and see what's happening behind the scenes. So make sure you check that out, especially outside of this workshop. So we're going to walk through the workshop today. It covers a lot of content is what I would say. And I think it's, I'm gonna be walking through it myself. It might be difficult for you to keep up with every single step. I would say there's sort of 3 ways you could think about going through this workshop. Number 1, you can try and keep up with me as you go. If you're gonna do that, again, download that GitHub repository and use those pre-configured branches to where you're just sort of looking at what's going on, you're deploying, but you're not actually writing out the code every time. I think that'll be easier for you. The second thing you can do is you can just go off on your own and do it. Use that workshop guide and sort of go through that. The workshop guide is going to have everything you need there, and that'll be great. Third approach is you can watch what I'm doing now and let some of those concepts sink in as we're sort of learning that, see what I do. And then if you want to, after this workshop is done, you can use that workshop guide and walk through it yourself and get a feel for it that way. So whatever sort of learning style works for you. We've got a bunch of people in the chat that are available to answer questions. I somehow lost the chat. Let me see. Oh, there we go. I got the chat back. So again, feel free to ask questions in the thing. We got a bunch of people helping there. I'll try and answer those as we go as well. And then I'm also available, after this workshop's done. I'm easy to find. You can find me or Pete or anybody else, and we can help you with these questions after the fact. So, and then finally, this is being recorded. And it'll get shared with you in some mechanism after this is done. So without further ado, with all that set up, let's get started here. And I just want to talk.
Alex,
yep, sure.
Would you like to announce the hash code and the link that is shared by Aman as well? But would you like to announce and how to use that?
Yep, sure. So if you look, Aman just posted this in the chat. And there's a event engine link. This is also in those setup instructions. If you click on this link right here where it says visit this website, you can open that up. That's going to take you to this event engine. It's got a pre-filled event hash here. You just click accept terms and log in, and you can go through the sign-in process there. So if you go through all those steps, what it's going to do is provision you an AWS account. Again, it'll be good for the next 12 hours for you to play around in, just a little sandbox account. It'll give you the credentials that you can put in your local machine and get up and running. Thanks, Amit, for the reminder there. Sheriff has a question. Will NPM version 6 work with the lab? Absolutely, yeah. You don't need a super advanced version of NPM. You just need to be able to sort of create a package JSON and use it to install dependencies if you would have any. So yep, that should work fine there. Cool. With that, I'm going to get going. If you want to be setting stuff up in the background, that's fine. I'm just going to kind of roll. Again, this recording will be available after the fact. I do have to kind of keep it moving as we go because we only have, an hour together and we have a lot of things we want to cover. So, just take it for yourself, whether you want to try and keep up, whether you just want to watch and do it later, whatever you want to do. But this is going to be available via recording, via that written workshop guide, all that stuff. So whatever learning style works for you. So without further ado, let's get started and just talk about what we're going to be doing here, right? We're going to be, this is a workshop that's showing how to create a serverless application, and particularly using DynamoDB and Lambda and how well they work together. So that's what we're going to be focusing on here. One thing I want to call out at the beginning of out of scope is DynamoDB data modeling, right? I really love DynamoDB data modeling. There are a lot of good resources on the DynamoDB site, documentation about how to model in DynamoDB, and it's a really deep and interesting topic. It's not something we're going to cover here because that's a pretty big topic on its own. So I would say go check that stuff out. What we're doing is more just sort of operational, mechanically, how does Dynamo work with Lambda? How do you deploy serverless applications? So two big things I want to cover in this workshop. Number one, what are the patterns for using DynamoDB in your serverless applications? And I think there are two different patterns that are pretty common that we're going to explore. Pete mentioned these. So number one is just using it as your primary database. So doing those data operations in your Lambda function where you're writing to your DynamoDB table or you're reading data from your DynamoDB table, just using it as your primary database to store data and display it back to your users. So that's going to be number one. We'll look at that one first. The second pattern we're going to do is processing data changes. So doing change data capture. Dynamo has a feature called DynamoDB Streams where you can enable this on your table. And then every time you make a write operation against your table, whether you're inserting a record or updating a record or deleting a record, they're going to drop a record of that change into DynamoDB Streams, and you can process that as you want. Whether that you want to process that and make some corresponding changes to your table, or maybe send it to an analytics system, or maybe fan out to other services in your application. You can do all sorts of interesting things reacting to those changes. So that's the second way we're going to be looking at using DynamoDB in this workshop. So that's the first thing we're learning, the two ways to use Dynamo. Second thing we're learning is just how do I deploy and manage a serverless application, right? What is a serverless application? We're going to be looking at AWS Lambda and what it looks like to deploy Lambda functions, but we're also going to be looking at infrastructure as code and how you manage your serverless applications, because when you're using this serverless applications, you're often tying together a lot of different services, whether that's AWS Lambda, DynamoDB for your data, API Gateway for HTTP endpoints, SQS for queuing, S3 for blob storage, all sorts of things. You need to have all this infrastructure, and the way you need to manage that is via infrastructure as code. So we're going to look at what that means, how you do that. That's where we're going to get into AWS SAM. Talked about downloading and installing the AWS SAM CLI and just seeing how that helps with that serverless process. So that's our high-level overview. We're going to do this in 4 different modules here. Each one has 2 parts. We're going to start off with just deploying our first serverless application. So I'm going to go over to VS Code here. The big thing we want to do in this particular part, we're not going to be working with DynamoDB here yet at all, but what we're going to do is just deploy our first serverless application. So we're going to write our first Lambda function. We're going to hook it up to an HTTP endpoint, and then we're going to invoke that and just see what that model looks like. As part of that, we'll get used to using AWS SAM and the AWS SAM CLI to deploy and manage our code. So 3 big services we're going to use here. First one is AWS Lambda. What is Lambda? Lambda really kicked off this whole serverless revolution now, 7 years ago, I think. And what Lambda is it's function-based, fully serverless compute. So what you do with Lambda is you'll upload a zip file or now even a container image that has some function code. You say what your function entry point is, and you just give that to AWS, and you tie it up to events. And you say, hey, when this particular event happens, I want you to trigger my code to handle that event. An event can be an HTTP request. It can be a batch of messages in a queue. It can be a batch of records in DynamoDB Streams. It can be a notification that something's been uploaded to S3. Lots of different events. But what we're doing is you have this reactive compute where when something happens, then trigger my compute. And that's what we're going to do here. So we'll get started with Lambda and deploy a Lambda we'll write and deploy a Lambda function. We'll also hook it up to API Gateway, which is just a way to add HTTP endpoints to your Lambda functions. So if we need to hook up events to our Lambda functions, API Gateway is a way to hook up HTTP requests to our Lambda functions. We're going to be doing that, and then we'll tie it all together with AWS SAM. So let's get started with writing our first Lambda function. What I want you to do is check out, if you're following around in the repo, check out branch 1.1. So you can do git checkout 1.1. Look at that, and it'll switch to that branch and show your code there. We're going to be writing our first Lambda function. If you're following along with the project instructions, this is going to be starting in module 1. And I want you to read the introductory stuff all the way to create your SAM template is what this particular portion is going to go to. So take a little bit to look at that. I'm not going to take too much time here, maybe just 30 seconds to a minute to maybe let you look around in the repo and see what we have, and then I'll explain what we're looking at here. But what we're doing first is writing our Lambda function that we're going to deploy. If you have any questions, feel free to put them in the chat. I'll try and hit those, and as well as all the great folks supporting this. see Thomas in the chat talking about using DynamoDB Streams for maintaining integrity with denormalized data. And yeah, that's a great pattern you can use to, if you have some denormalization, you can pay attention to changes and make sure that gets duplicated out to other items down the line. Yeah, so that can be a great pattern there. Lots of good patterns with DynamoDB Streams. All right, I hope you're oriented to branch 1.1, looking at some of that code. Again, we're going to be moving kind of quickly, so if you want to just be watching, that's fine. Don't declare workshop bankruptcy and get frustrated. You'll have these accounts for the next 12 hours. You can look at this workshop at any time. So make sure you just sort of soak in the concepts as we go here. But the first thing we're doing is creating our Lambda function code. And what we did here is we created a source directory for our code. So I created a source directory, and I created a file called main.js, and that's going to hold our function code there. So let's pop that file open. 3 big things I want to point out about this file. Number one, you can see at the top, we're exporting a function. And this function is called handler. It could be whatever name we want, but we're just calling it handler in this case. But we're exporting a function, and Lambda is function-based compute. But it doesn't mean you're necessarily uploading a single function, but you are uploading a bundle of code that has a particular entry point, right? And that has to be your function handler. That's what we're exporting here. This function is going to be the particular entry point to our code when an event comes in to trigger that code. So we have our exported function. If you look at the function signature, it takes in 2 arguments. So it takes in one called event, one called context. Remember that a Lambda is event-driven compute, so it's going to be operating on a specific event. So that first argument is the event that actually triggered it, right? So if it's an HTTP request, this will include information about that HTTP request. What path did it come in on? What HTTP verb did it use? Is it get, post, put, delete, whatever? What headers does it have? What query string parameters? Does it have a payload body that I need to parse out and operate on? So it'll have all that information about that HTTP request. If you have other event types like SQSQ, this could be a batch of messages to process, DynamoDB Streams, batch of records to process, different things like that. But that event argument is going to contain all the detail that's specific to the event that triggered your function. The context argument, on the other hand, is just going to include sort of meta information about your function. It'll include the function name, its log group name, how much memory it has available. Each function has a maximum time it can run, so there's actually a function on that context object that tells you how much time is left to run there. So I don't use context a whole lot, but just be familiar with that. So that's the second thing, just that function signature. The last thing is the return response in our function, right? So we're going to be hooking this up to API gateway. We're going to give it an HTTP endpoint. So our HTTP request is coming in. We also need to return an HTTP response. So we need to return some object that indicates to API gateway how they respond to the client that called it. So what we're doing is we're just going to be returning an object. You can see we can return things like a status code, right? Because if things go well, we can return a 200, but we could also return a 401 or a 500 or whatever it is to indicate that something went wrong in that particular request. We can also include a payload body here, which we're doing. I'm just including some JSON, a simple message of hello world. I'm also including the event that came in with our request. This is just going to make it easier. Once we hook this up to an HTTP endpoint, we can inspect that event, just see what it looks like, just to give us a feel for that event-driven nature, see how we can manipulate that event and use it in our function. So that is step one. We've written our first Lambda function, but there's nothing really going on with this function. It's still on our machine locally. What we need to do is find some way to create the infrastructure, get this uploaded to AWS. So that's going to be the next part of this, where we're going to be creating our SAM template. So next, I want you to check out GitHub branch 1.2. So git checkout 1.2. Take a look at that. This is going to be in module 1 all the way to the end. So you'll be creating a SAM template, doing a build and deploy process. I'll give you just a few seconds to look over the SAM template, and again, we'll come back and walk through it just like we did with the function code here. Question from Corey. Do I use some sort of CFN linting extension? So because what we're going to be doing here in this SAM template, it's going to be CloudFormation and you need to make sure you have the properties right, if they match and different things like that. And there are some linters to help with that. I think I have one installed, but I can't remember. I'm actually quite bad with VS Code, so my configuration isn't great, but I know there are some good ones out there. So I would look to someone smarter and more skilled than I in configuring that in how to do that. But I think there are some pretty good linters in there, give you some autocomplete, give you let you know when something's wrong, things like that. All right, I'm going to keep this moving, just keep us on time here. So I'm going to open up template.yaml. This is a file that we created as part of this step 1.2. This is going to be our SAM template. And again, what SAM is, this is a serverless application model, and this is a way for us to define infrastructure as code using CloudFormation. So this is a CloudFormation template. Just want to walk through the steps here. At the top, we have some just sort of generic boilerplate type stuff. We're saying the template version. We also have this transform block here using the AWS serverless transform. What this means is that I'm opting into the serverless application model transforms. So CloudFormation allows you to provision all sorts of resources across AWS. What the serverless application model does is give you some higher level constructs on top of those like low level resources that allows it, just makes it a little easier to provision this stuff using CloudFormation. So we're gonna pull into that transformation there. I'll show you a little bit. I'll talk a little bit how that works in just a second. Then we got a description. All right, so in our CloudFormation template, the meat of it is going to be in this resources block, and that's saying what particular resources we want to provision using CloudFormation. So in this resources block, this is going to be a map, right? And we can just create the resources we want here. So the one resource we're creating here is our Lambda function. So we're just giving it a name, main function. This name you give it is what's called a logical ID, and it's going to sort of uniquely identify that resource within your template, and it will identify it across deploys as well. So you don't want to be changing the name, the logical ID of this particular resource. So I'm calling it main function because it's using that main.js file there. Whenever you create a resource in CloudFormation, you need to specify two things: the type of resource you're creating, and then the properties for that resource, the various configuration you have. So the type we have here is an AWS serverless function. The fact that it has this sort of serverless namespace here means that it's in that serverless application model set of helper resources here. So it's creating a function, but it's helping us do some things that just sort of the low level CloudFormation stuff won't do. Within that, we have properties that we need to specify. So we're specifying the code URI, just like what's the root directory for our application code. I'm just saying it's this current folder we're in. Then you have to specify the handler. Remember that Lambda is event-driven compute, so you need to specify what's sort of the entry point to your function when that event comes in. And that's what we're specifying here, right? We're saying in the source directory, in that main.js module, we have a function called handler that's exported, and that's what we want to call when we get an event that triggers our function. Next, we have our runtime. Here we're using Node.js 14. You can use different versions of Node. You can use Python. You can use C#, Java, Ruby, or bring your own runtime as you want to. And then finally, we're going to hook up events to our function, right? Because Lambda, again, is event-driven compute. So we upload our code, but until we hook up events to it, that code's just going to sit there. So we need to say, hey, what's going to actually trigger our function? In this case, we're going to put an event of type API. So the type API indicates, hey, this is an API gateway event. We want to be hooking up an HTTP endpoint to this particular Lambda function. And when an HTTP request comes to our API gateway on this configured path and method, it's going to route to this Lambda function. So that's type API. And then you see the properties there. I have a path. It's going to be on that root resource, just the slash with a method of get. So that's what we're provisioning here. Again, I said this is part of the AWS serverless application model. So it's actually, when we're creating this, it's not creating a single resource. It's going to be creating a function, but it's also going to be creating an IAM role that's used for permissions. It's going to be creating log groups. It's going to be creating an API gateway when I hook up this event here, and different routes and paths and different things like that for API Gateway to get that to work. So this is actually helping you a lot. You'd be creating a lot more resources if it didn't have this sort of helper serverless function resource in the serverless application model. Sheriff, great question. I'll get to that in just a second. I want to get through a deploy here. So once we have our resources, right, this is specifying all the things that we're creating. You can also have what are called outputs, right, which are things once your template is deployed and it's done, these are output values that you can have, because you're going to have some values that you might need that aren't going to be known when you deploy your application, right? There's things that are generated once your resource is created. So for us, we want to get the API endpoint, right? We're setting this API gateway for our Lambda function, but we want to know what the URL is so that we can go and invoke our function. That's what this is setting up here. All right, so that's the basics of that SAM template. Now we actually want to deploy our application, right? Because we have our function code, we have our template describing what resources we want to deploy. Now we actually need to submit that to AWS CloudFormation to get those provisioned. And this is going to be a two-step process when you're using AWS SAM. First, you need to build your application. So the command you'll use there is called SAM build. And that's going to build your application, build the different functions you have. We'll look at the stuff in that in just a second while our deploy is going on. So first, you always want to build, and then you want to do SAM deploy. So build just sort of preps your stuff. Deploy actually deploys it. The first time we run this, we're going to have to do SAM deploy, and you have to do -- guided to just set up some initial configuration for your Lambda, your SAM application here. All right, so now it's asking me for some of these things, including a stack name. I'm going to do Lambda DynamoDB workshop for my stack name. It's going to give me AWS region, things about confirming changes, allowing role creation, rollbacks. Just a few different things there. If you look in the workshop guide, it'll tell you how to answer these. The defaults work for almost all this stuff. And then it's going to do that deploy. So now that deploy is actually happening, right? I've described the resources I want to create in my SAM template, and now it's going out and creating those. While that deploy is happening, I want to look at a few other things. Notice that I now have this samconfig.toml file in my repository. When I did that -- guided for SAM deploy, I told it at the end, hey, save these configuration options for later. This is what it put in here. So it has my stack name, it has my region, all that sort of different things. Now going forward, all I have to type is SAM deploy. I don't have to do -- guided to do that. The other thing we were talking about SAM build earlier on. If you look, excuse me, if you look in the .aws SAM directory within your application, you'll see the built sort of package stuff. There'll be a .aws SAM directory and then a build directory within that. It has your compiled SAM template. This should look very similar to your the template you already wrote. The big difference here will just be the code URI. They're going to sort of repackage your code for you and put it in this build environment. So it changed that slightly. You can see also you have this, excuse me, you have this directory main function that is for that function that you created. It sort of compiled that all together for you. It would install dependencies if you had, Node dependencies or Python dependencies, whatever you have there. It would do all that for you. So that's what's happening. All right, so you can see that our deployment was successful. So it says successfully created, updated this stack. You can also, you can also see these outputs, right? We had those outputs in our file that we wanted to get, including the API endpoint for our application. So I'm just going to copy this value right here. Oops. Copy that value, and let's go visit that in a browser right now. Zoom in a little bit. All right. So collapse a little bit this down. I have this with like a JSON prettifier. If you do this in your own browser and you don't have that, it might look like just a giant blob of JSON. But this is an actual response that we got back from our function, right? So we called that HTTP endpoint that's hooked up to our Lambda function. It triggered our function. It sent this back to us. You can see we have our hello world message here. We also have this event object, right? And this is the event that we got in our function when that Lambda function was triggered with that HTTP request. You can see it has things like the resource, the HTTP method there. We've got a bunch of headers that we want to look at if you want to look at the headers. You can also see additional information about the request. At the bottom, it has a body. So this is a GET request, so it doesn't have a payload body. But if you're making a POST request, maybe there's some JSON in the payload body there. You can also see there's query string parameters, and this is null, right? But sometimes you might want to use query string parameters to sort of customize some of your logic there. So let's just take a look at how we can actually customize this, how this event changes. So with query string parameters, it's currently null. If we go up into the address bar, I'm just going to add a query string of name equals lambda, right? So adding this new query string, let's do enter there, collapse our headers down. See, we have a pretty similar event here, but now we have this query string parameters object here that has a key name and a value of lambda that matches up with those query string parameters. So if we want to pass data to our lambda function using query string parameters, path parameters, payload body, that's how we do that, and that's how we access that in our lambda function. All right, so that's step one. Basically what we've done here, pretty straightforward. We deployed our first serverless application by first writing a Lambda function, then creating that SAM template that describes the function we want to create. Then we did that build and deploy process to actually deploy our infrastructure. I'm gonna have to start speeding this up because we only got 35 minutes left. So I want to move on to module 2. This is where we're going to be creating and interacting with a DynamoDB table. We're still not going to read and write data from it yet. We're just going to sort of interact with it and see, how do I provision a table? How do I also interact with it in my function code? So go ahead and take that on as you look in module 2.1. And we're going to check out GitHub branch 2.1 for this one. So open up 2.1, take a look at some of the changes in the template.yaml. I'll give you probably just about 20 seconds here, and then we'll go look at that together and then see how to deploy that.
I'm a big fan of SAM. It's an amazing simplifier. I mean, there's so many things that it's taken care of here.
It's really true. And if you go, we didn't look at the, as you're creating, when you create your deploy, if you look at my console output, it shows all the different things it's creating, and you can see it's creating an IAM role, it's creating a Lambda function, it's creating an API gateway REST API resource, and then within that, Lambda permissions, an API gateway deployment, API gateway stage, all sorts of different things that it's creating, where it abstracts some of the really gnarly stuff underlying Lambda and API gateway. And now all you're saying is, hey, here's my code, here's my API route that I want to do, marry those together and do all the stuff that helps me with that. So I love it.
Super powerful. Yeah.
Cool. So let's move on to this part 2.1. What we have here is we're actually provisioning our DynamoDB table now, right? So we already provisioned our main function. I'm just going to collapse that. This is in our SAM template. I'm going to collapse that down. We still have that. We're just not looking at it right now. And now you can see we have another resource. I'm calling it DynamoDB table. You can call it whatever you want, as long as you make sure you keep that name. And remember, we have two things we need to set up for our DynamoDB table. We need to specify the type of the resource we have here. So it's AWS DynamoDB table is the type of resource. And then we also need to specify the properties, right? This is the configuration for our DynamoDB table. Not going to go super deep into the properties. The first two, DynamoDB is very primary key driven, as Pete was mentioning, and you can use just that partition key. You can use a partition key and a sort key for your table. In this case, we're just setting up a table with a simple primary key, has just that partition key. It's a key called ID, which is a value of string. You don't need to get super deep into that for this particular case. Again, that's more in the data modeling realm. Last thing we need to put here is provision throughput. So with DynamoDB, you need to specify how much capacity you want. You can specify your read capacity and your write capacity separate from each other. In this particular case, I'm just provisioning 5 units of each. That's going to fall underneath the free tier. If you don't have a good sense of how much capacity you're going to need, Dynamo has an on-demand billing mode where you don't have to pre-provision any of that stuff. You just say, hey, I'm going to issue reads and writes against Dynamo. You send me the bill at the end of the month, charge me for each one of those. It's a little more expensive on a per request basis, but it saves you a lot of time from configuring that capacity. So take a look at that. The last thing I want to say here is there is a property in DynamoDB called table name. And when you're interacting with a DynamoDB table, you're going to interact with it via its table name. I could specify that here in my table, but I generally don't. If you leave that out, CloudFormation will generate a table name for you. The nice thing about this is it makes it a little more portable if you have multiple different stages for your same application, right? You have dev, test, staging, prod, whatever. You don't have to customize the DynamoDB table name for each one of those. You can just rely on CloudFormation to handle that for you. So you can do that. But then you do need to figure out that table name somehow, right, to actually interact with it. So let's just create another output just to see how we do that. Like we did outputs with API endpoint, we're also going to do with our DynamoDB table name. So we're going to create a new output. The description is going to be the name of the DynamoDB table. For the value here, what we're doing is we're using this built-in CloudFormation function called ref. So you use it with !ref, and then the resource you actually want to refer to. So in this case, it's DynamoDB table. So that's the logical ID there. And what that's going to do is return the table name of a resource. And every single resource in CloudFormation has a ref, which will return something about that resource. Let's just do a quick search here. So if you're working with CloudFormation resources, the thing I always do is just type in the type like this, and it's always going to come up first. So AWS : service : resource. So in this case, DynamoDB table. You can pop that open there. This is going to be the CloudFormation reference documentation. It'll teach you about all this stuff. I really like how it's laid out. Once you sort of start to understand CloudFormation, this page is going to be really helpful for you. So it'll list all the different properties you want to have that you can configure here. And it'll tell you which ones are required, which ones are not required, different things like that. Check that out. But it's also got a section called return values, and that's where that ref we were just talking about, what that's going to be. So for this one, it's saying ref will return the DynamoDB table name. So when we use that ref function on a DynamoDB table, it's going to return the table name back to us. So that's what's going on there. Now that we've sort of configured this, let's do another build and deploy. So again, we do sam build just like we did before, and then sam deploy. And note that I don't have to do -- guided this time because it has that configuration in my samconfig.toml. It's picking up all that stuff. I don't need to do it again. I'm going to start deploying before I explain going forward, just so we're not hung up by the deploy going forward. So again, what we're doing here is creating our DynamoDB table. We added that to our CloudFormation template, our SAM template, and now we're doing a new deploy. It's going to look at that and say, oh, now they've declared this DynamoDB table, which wasn't in there before. So we're actually going to create that resource for them. So Uthman, good question. So yeah, will this new template create new resources or just update? So it's basically going to do a diff based on the state that currently exists and do all the work to get it in the state that it wants to be in. So in this particular case, we're still going to have an API gateway, but because we didn't change anything about API gateway in this deploy, it knows to just skip over API gateway. It doesn't have to do anything there. But as it looks at this, it's going to say, oh, there's a new resource, DynamoDB table. We don't have that one. I'm gonna go create that resource and make sure that's ready to go going forward. It's a good question. So that's the nice thing about CloudFormation. It's a declarative format, and it's going to do all the work to sort of reconcile your existing resources with your desired state based on a new deploy and merge those two in a nice way for you. Ivica, where is the state? Is it local? So the state is actually going to be in the CloudFormation service itself. So when I run SAM deploy, what that's doing is it's submitting that template in my build directory. It's submitting this template up to CloudFormation. And CloudFormation is going to say that and say, okay, our most recent deploy, here's the template text for it, and we'll keep that. And then the next time you deploy, it'll get that new template, and it'll diff those two, and it'll say, okay, here's what I want. Here's what I currently have. I'm just going to update exactly what I need. Yeah, and so you're referring to Chalice there. Chalice is for those that aren't aware, it's like a Python web framework that uses Lambda. I think as you're sort of alluding to, it maybe does it in a more imperative way of how it sort of makes those changes and or at least where it's storing those state, and it can get into trouble there. The nice thing about CloudFormation, totally managed service, right? It's going to store your state up in the cloud and do all that diffing for you. David, so like CDK and Pulumi. So CDK is a tool on top of CloudFormation. It allows you to write imperative code that compiles down to CloudFormation and then is submitted. Pulumi is sort of a similar type way, not using CloudFormation under the hood because it's a third-party thing. But again, same sort of thing, a way to write imperative code that then generates declarative code. Yeah, and if you're familiar with Terraform is very similar in like the declarativeness of CloudFormation and SAM, different things like that. The one reason I think CloudFormation is so popular in the serverless world is because it has these serverless abstractions on top of it, to where it creates that function. Creating just this function is creating all those low-level things that you don't need to care about. Whereas in Terraform, you would have to create API gateway and the different paths and routes and different things like that. You'd have to create your IAM role. You'd have to package all that together. You can maybe use modules or things like that, but it just adds a little more complexity than some of these other ones. All right, I got to keep rolling. These are great questions, though. I'm going to move on to branch 2.2. And what we're going to do here is we're going to see how to interact with our DynamoDB table in our function code. We're not going to read and write to it. We're actually just going to describe it, right? So we're going to call the API to describe some information about our code. But as we do so, we're going to learn some about how you interact with that DynamoDB table in your function code. So Reagan, one last question. Is it possible to separate those two resources? Yeah, you absolutely can. So you can have, I just collapse those down just to make it easier to read, but you can have lines between them or whatever. I mean, they just have to be at they have to be at the same level, the top level on the resources. All right, so let's see how to interact with DynamoDB table in our Lambda function. The first thing I want to do is what are the mechanics of working with an AWS service? And if you're working with an AWS service, you're almost always going to use the same 3 steps to interact with it, right? You'll have the AWS SDK installed in your environment, and you'll import the AWS SDK. Then you will create a service a client, you'll create a client for the service you're working with. So whether that's DynamoDB or S3 or SQS, whatever, you'll create a client for that specific service. And then on that client, you will call methods to interact with that service. So let's look at those first 2 steps, that client creation process. And I have this file under the source directory called client.js that's going to show us a little bit of what's going on here. This is just a little helper file that I often have in my repository. You can see us importing the, oops, sorry. I just realized I'm going to do a SAM build. I'm just building and deploying now just to get us ahead so we're not waiting on a deploy later, but since we're getting short on time here. Now in this client.js file, we're importing the AWS SDK here. You can see later on, we're actually creating a new DynamoDB client. So this is a new DynamoDB client here. What I have in this file is this little function called getClient that I'm exporting. And this is going to be used by my various functions in my service here. But centralizing client creation can help you in 2 different ways when you're working with Lambda. Number one, it helps you to centralize just some configuration options, right? So one thing I like to do is I like to set the connection timeout and just the general timeout to a lot shorter, to 1,000 milliseconds, just 1 second, where I think the default is like 30 seconds. I just want to have a shorter one. So if something's hanging for whatever reason, just cut that off and I can retry it a lot quicker. So I like to centralize that configuration logic so I don't have to do that every single place I'm creating and using a client across my application. So that helps there. The second thing, and really the bigger performance optimization here, is we're creating a Singleton client. I see Oliver sort of calling this out here. But the way Lambda works, right, is when an event comes in, they're going to spin up a container with your code in it to handle that particular event. That container instance is only handling one single event at a time. So an HTTP request comes in, it's handling that event. Once it's done, then it's just sitting there idle, and they're going to keep that container alive for a while. And let's say a few seconds later, a new request comes in, right? It can reuse that same container. And what you can do is with that container reuse, you can reuse resources like AWS clients to make it more efficient for subsequent requests. So, AWS uses HTTPS for all of its interactions with its services. That requires, a TCP connection. You got to do the three-way handshake, all that sort of stuff. But once you've done that with the first request, if you use Keep Alive, you keep that client around. You don't need to redo that three-way handshake every time. And it's going to be a lot quicker in subsequent requests to reuse that client. So that's what we're doing here. You can just see in this client code, we're setting client equal to null there in the global namespace. Now with this get client, the first time we run this request, it's going to look here and say, if the client exists, return the client. Well, the first time we run this, the client doesn't exist, so it's going to skip past this. So what it will do is it'll create a new client and assign it to that client variable and return it back. So this first time we run this code in a particular Lambda function, it's going to have to create that new client. It's going to be fresh, and they'll have to do the TCP connection. But the second time, third time, fourth time we're using this Lambda function, we'll have a client initialized, right? It'll already have its TCP connection, and it'll just hit right here and return that Singleton instance of that DynamoDB client, and it can reuse that HTTP connection there, which is really great. To do this in Node, you also have to set a particular environment variable that we'll talk about in just a second. But anyway, I like to centralize this logic for my client there. Now that we've got that, let's go take a look at our main function and what we're doing there. We've imported our get client function here. So that's one thing I like to say. We talk about Lambda functions, but it doesn't mean you can only have a single function in your code. It means you have a handler entry point function, which can call other functions in your code as it needs to for that. So including this get client code. You can see here what we're going to do is call, we're going to get our DynamoDB client, and then we're just going to do a describe table operation against that DynamoDB API. So we talked about with the AWS SDK, you import the SDK, you create a client, that's what get client is doing, and then you call a method on that client, and that's what this describe table operation is doing here. You can see here we need to pass in the table name of our DynamoDB table, which we don't know when we create our, when we create this function. So what we're going to do is pass it in as an environment variable. I'll show you what that looks like in just a second here. Once we get that response back, we're just going to return it in our HTTP response. So rather than returning the event, we're now returning the response back. All right, two more things I need to show. This is going to be in our DynamoDB template here, or sorry, our SAM template. So first of all, we talked about how we need to know our DynamoDB table name in our Lambda function. How do we do that? We inject it as an environment variable. So if you look at your main function here, your Lambda function, you can go down and there within properties, there's an environment section, right, where you can pass in environment variables. We're going to pass in one called table name, which matches up what we have in our function code. And again, we're using that exclamation point ref function on our DynamoDB table, which remember is going to grab our table name. Remember when we were looking at the DynamoDB documentation, we saw that ref is going to return the table name back to us, and that's what we want to pass in. Also, if you're doing that node connection reuse, you need to set this environment variable here as well. So it's AWS Node.js connection reuse enabled. You need to set that to 1. This is only for Node.js, just some quirks around how the default Node HTTP client works, so you need to set that up. All right, in addition to environment variables, we also need to set up policies, IAM policies for our Lambda function, right? Because everything within AWS is controlled by IAM, which is Identity and Access Management, because they want to make sure that if you're making requests for to access a resource, that you actually have permission to that. And that applies to our Lambda function as well. If our Lambda function is saying, hey, describe this table to me, we want to make sure our Lambda function has permissions to do that. This is how we set that up by using this policy statements in our SAM template here. So we set up policies, we add this particular statement. What this statement is saying, hey, we want to allow, so we have an effect of allow, we want to allow this particular permission we're specifying. The action we're specifying here is DynamoDB describe table. So when you're working with IAM, it's always going to be the service and then a colon and then the actual method that you're running there. So the method we were calling was describe table. That's what we're doing. And then we specify the resource we're calling it on, right? So it could be all resources, but we don't want to give this Lambda function permission for all resources. We want to lock it down to a specific DynamoDB table. And that's what we're doing here. We're getting the ARN from our DynamoDB table resource. This exclamation point get at function is similar to this ref function, but it allows us to get a different attribute. What we need here is the ARN. If you go back and look at that CloudFormation documentation in the return values, this get at function tells you what kind of attributes you can get from that DynamoDB table. All right, so that's what we have. Let's go back and refresh our API, which we already deployed here. You can see we still have our hello world message, but we also have our table response. This is the response we got from describe table, and you can see information about our table. You can see our table name. You can see the table ARN. So when we needed to put that ARN in for that IAM permission, this is what it's actually passing in there. Item count, table size, and bytes, all that stuff. So you can see based on this, we were able to call describe table from our Lambda function. We had permissions to do that. We had the table name and all that as well. All right, so that's module 2 of this workshop. Again, so what we've done so far is deployed our first serverless application. We have a function, we have API gateway. We saw how SAM works. Now we've created our DynamoDB table. We've also, injected our table name in. We've set up that client.js code to manage client management there, and we have our IAM policies. Now in this module 3, we're going to go on to actually writing to and reading from our DynamoDB table. So I'm going to git checkout branch 3.1, and I'm just going to keep going here just since we are kind of time crunched again. So I'm going to do a SAM build and SAM deploy while we're explaining this. But what we're going to be doing is writing to and reading from our DynamoDB table. What we want to do is add 2 HTTP endpoints. So the first endpoint is going to be /tag/ and then just capture a tag name, /tag/ technology /AWS /NBA, just different things. What we're doing is a page counter based on these different tags that people are counting. Every time someone visits one of those tagged page, we want to record it in DynamoDB and just maintain a counter for that particular tag. Then later on, we'll allow people to visit /counts /tag name and see how many views we have for that particular counter. All right, I'm losing my voice here. So with that, let's start with that first one where we want to record a tag visit, right? If someone visits /tag/ something, we want to record a visit for that particular one. I always like to start with my function code. So let's go within our source file, go to recordvisit.js and see what we have here. If you think about this in our Lambda function, I think about it as a 3-step process, right? When our Lambda function gets triggered with this event, I need to, number 1, figure out what my the tag name is, right? So I need to extract that from the HTTP path value there. So if someone goes to /tag/AWS, I need to pull out AWS and realize that's what I'm incrementing here. Once I have that tag extracted, now I need to increment it in DynamoDB, and then I just need to return a response to my to the client that called me. So let's take a look at this here. We have our Lambda function, we have our handler. You can see at the beginning here we're extracting this tag value. The nice thing is we don't have to actually pull it out of the path itself. You can see we have event.pathParameters.tag. I'll show you in just a second in SAM how we're actually going to configure that so that it'll extract that for us. Once we do that, we're just going to do an update item operation. where we're going to increment this value. This update expression is basically just saying increment this value. If it doesn't already exist, set it to 0 and then increment it. Otherwise, just increment the current value. And then we're going to return a response here. Similar to the response we've already done. The big difference here is now this is HTML. We're returning some very ugly HTML that I wrote myself with inline CSS and everything. So you can return HTML. You can return any type of content you want for the most part from API Gateway. You can also customize the headers here. So I was returning application JSON before. That's going to be the default for API Gateway. But if you want to return HTML, you can include headers that say, hey, this is text HTML, so your browser knows how to handle that accordingly. So that's that record visit function. Let's go to our template.yaml just to see what we have here. And we still have our main function. I'm just going to collapse that down. I'm going to look at the record visit function that we just created here. This is going to be pretty similar to that main function that we already had. So we're creating a resource of type AWS Serverless function. We have our same properties, right? That code URI, the handler is going to be different because it's going to be this record visit.js file, not the main.js file, but otherwise very similar. Same runtime. Events, we're doing an API event again. The big difference we have here is if you look at the properties here for our path, notice that our path is /tag/ and then in curly brackets tag. And what this gives us, we're just setting up a path parameter and saying, hey, there's a dynamic value that we have here, right? Because people can go to /tag/technology, /tag/AWS, /whatever. We don't want to have to list every single one of these out to match again. So what we're just saying is, hey, if you get /tag/ and another string, capture that value, route it to this Lambda function and pass it into me. And that's where I could pull it out with that path parameters in my Lambda function. Again, it has the get method. Last two things here, just environment variables and policies, which we already saw. Just notice that the policy is a little different. It's an update item policy on this one. So let's go check this out. Heading back, and I know I'm sorry we're going fast here. I gotta really roll. But if I go back here and I do /tag/ and let's just visit the technology tag, right? We want to visit this particular tag and record that visit. So we're doing that for tag technology, and you can see your visit counts, right? We've actually recorded this for technology. You can see you can check the count. Let's refresh this a few times just to get a few hits on this. We could also do this for, let's say, AWS, right? So you can see it's dynamic based on the actual value that we're passing in. Then we can check the count for our tag here, but it doesn't work because we haven't implemented that. So let's go implement that next. Going back to our code, let's check out 3.2. And what we're doing in 3.2 is very similar, right? We're adding a new HTTP endpoint. It's going to be /counts/ and then the tag name. So if you want to view the counts for a particular tag, you can do this here. Again, the process for that Lambda function is going to be very similar, where it's going to be extracting the tag name from the path parameters. It's going to read from DynamoDB rather than write to, just to get that count. And then it's going to return it back to the user in some HTML. So let's go take a look at all of that. I'm going to do a SAM build and SAM deploy to get that working.
Hey, Alex,
all right, so now,
while this is building and deploying, I want to quickly call out that I posted a link to provide survey. So to everyone, please provide your survey. You can also scan the QR code provided in my message. Scan the QR code on your phone and also submit the survey. Thanks, everyone.
Awesome, thank you. I'll just repost that just in case people lost it. But yeah, thank you, Amit, for calling that out. And yeah, would really appreciate any feedback on this. This is the first time we're doing this particular workshop, so anything we can do to improve it would be great. And we really appreciate you all taking the time to attend and hope it's been useful to you. With that being said, let's go back to our code here. So we have view counts code going to be pretty similar to what we already have, right? We're extracting the particular tag we want to do there. Then we're doing a get item request that's reading from DynamoDB and getting that particular counts. You can see once we get that response back, we'll set that count equal to 0 and say, hey, if this item exists, we'll actually just parse it from that. Otherwise, we'll use that default of 0 and then return a response to our user. So nothing too groundbreaking there. Same thing with our template. Let's go back here and look at our new function. We have a view counts function. All this is going to be the same as what we have here. You know, we're using, again, a path with a path parameter in it. So it's /counts/ curly brackets tag there that's going to extract that for us. We have our environment variables. The only one sort of new unique thing that I want to call out here is in this policies section. You know, for our IAM statements, we can create those IAM statements as we have before with the effect allow. You know, here's the action and the resource. Or SAM has what are called SAM policy templates, and these are like pre-configured templates for very common access patterns. So they have one called DynamoDB read policy. If you want to just give read access to your DynamoDB table, you can use this policy template. You just have to pass in the table name there, and they'll do all the configuration there under the hood to make that work. Corey, you're saying, is there a particular setting in the template to make that path parameters object available? Yep, the syntax you want to use here is curly brackets around that dynamic part of your path parameter. So you can see in this path configuration for the event on this function, I have these curly brackets around the tag. And what that means is when something gets routed to my Lambda function from this route, within that event object, it's going to have a path parameters object, and within that it'll have a key of tag and whatever the value happens to be for that particular invocation. Cool, so now we've got that, we've got it deployed. So let's go check this now and click the count for the tag AWS. Hey, and now it actually works, right? So we've implemented this. The tag AWS has one visit. Let's go check out the technology one because we visited that a few times as well. That one has 5 total visits. So again, we have this dynamic stuff we're reading from DynamoDB. If we go to something that no one's been to yet, like NBA, hey, the NBA has no total visits, no basketball fans around here, I suppose. So we have that. So what we did in this third module is we're actually writing to DynamoDB. We're reading from DynamoDB. As we saw that, we saw a little bit more about IAM permissions. We also saw how to use path parameters, right? If you have a dynamic part of your HTTP path, which is going to be common if you're using a REST API, right? Think like /users/user ID or something like that. You know, you need to capture some of that, and those path parameters is a good way to do that. We'll keep on rolling to the fourth module here. We talked about how there are two patterns of using DynamoDB in serverless applications. One is for direct data operations, right? Writing to your DynamoDB table, reading from your DynamoDB table in your Lambda function. The second one is DynamoDB Streams. So let's hop into that now. I'm going to move on to part 4.1 and again do my build and deploy. So what DynamoDB Streams are is when you enable this on your DynamoDB table, it's going to give you a change log of all the write operations that happen against that table. So every time you change an item in DynamoDB, insert, update, delete, it's going to drop a record of that change into a stream that you can then process downstream. So the first thing we need to do is enable streams on our DynamoDB table. 2 big configuration options you need to set here. Number one is what's called the stream view type, and it's basically saying for each record you put into the stream, how much information do you want about that change? And at the very sparse end, you can say, hey, just give me the primary key of the item that changed, but don't give me any details about the particular operation itself, other than if it's an insert, update, or insert, modify, or delete. But other than that, don't tell me what it looked like before or after. On the other end of the extreme, you can say, show me the item as it looked before the operation and show me the item as it looks after the operation. So you get new and old images of that item before and after that change. That's really useful, especially if your items aren't super big, because then you can see what changed and do some interesting stuff off of that. So that's one thing you need to configure is the stream view type. Excuse me. The second thing you need to do is configure is just the stream mechanism. So you can use the default DynamoDB Streams mechanism. This is just built into DynamoDB. You don't have to manage scaling or anything around that. You can also choose you can alternatively choose to send your records to Kinesis streams, where you're managing the streams yourself. This gives you a little better fan out on reading from those stream records, but it does mean you have to manage the capacity there. So let's take a look at enabling these streams for our DynamoDB table. This is in our SAM template here. You can see I have our DynamoDB table. I have all the other properties I had before. The only thing that's different here is this stream specification property that I'm doing here. When I add this stream specification, what I'm saying is I want to enable DynamoDB streams for my table here. And I'm specifying my stream view type. I'm doing new and old images. So this is the most expansive option. I'm saying, hey, whenever a change happens, show me the item as it looked before the change and the item as it looks after the change, so I know what changed and can operate on it that way. So we've got that enabled. Now let's actually process our DynamoDB streams. What we want to do here is monitor these DynamoDB streams from our table and just maintain a global site-wide count of all the visits to our table, right? So we've been tracking visits on a tag by tag basis. So AWS is separate from technology, is separate from MBA, all that. But now I want to say, you know, we've got 10 visits to AWS, and we've also have 100 visits to our site as a whole. So what we're going to do is just process that DynamoDB stream, and every time we increment a tag, we're going to group those up and increment our overall site counter as well. So first thing I want to do, and I realize we're hitting time here, so if you do have to jump off, I understand that. Yeah, it should be about another 10-ish minutes or so. Let's check out 4.2. I'll do a build and deploy. First thing I want to do is just look at, I have this file event.json, and this is just giving us a sample of what that event shape is going to look like for DynamoDB streams, just to see what those records will look like. So it'll be an object. It has this records key, which is an array, and it's going to contain a couple of different DynamoDB stream records. You can see in here, it's going to have a DynamoDB key within there that includes, you know, the primary keys for the item. It also includes, you know, the new image for the item. So this is how the full image looks after the item changes. You can also see down here, there's an event name of insert. So we're indicating, hey, this is an insert operation. And that's the reason this only includes the new image. There wasn't an old image because we're inserting this item for the first time. Additionally, here's another event we can look at here that has both the old image included and the new image included, because this was a modify operation. So it's modifying an existing item. Because of that, we have the old image, we have the new image. So again, what we want to do here is we want to be paying attention to that stream. Whenever we're updating a tag, we want to just gather those up and increment our overall site counter. One thing we want to be careful of is we don't want to increment whenever we're updating that global counter object. Otherwise, we'll infinite loop ourselves, right? Like if someone increments AWS, we'll see that, we'll process counter, but then because we're updating that counter, it's going to put a stream record in, and we'll just sort of infinite loop and go and circle there. So we want to make sure we're filtering those type of events out. So let's go in our stream processor function here. This is just going to be operating on batches of events from our DynamoDB streams. You can see here, the first thing we're doing is filtering our records down. So we're just on that event objects, we're looking at the records and filtering, and we're making sure that it's either an insert or a modify operation, right? Because we want to be adding a new tag or modifying an existing tag. We also want to make sure that the item being manipulated was not this counter key that we're using to keep track of our operations. So we're filtering those ones out so we don't infinite loop ourselves. Once we've done that, we're just going to do an update item operation to increment those counters, and the increment value is going to be the number of filtered records in that that we got in that batch. Last thing I'll say here is we don't have a return on this one, right? Because this is like a more asynchronous operation processing these DynamoDB stream records. We don't need to return anything back like we did with a Lambda function that's connected to API gateway that needs an HTTP response back. So we can just, you know, as long as we return successfully, that indicates we process that batch and we can go on to the next batch of records in our streams. Another thing, I'm also just updating the view counts. I won't really go through that, but when we're doing that view counts one, we're fetching the records for the tag. We're also fetching the total counter as well and returning that in the HTML. All right, last thing, let's go check this out in our SAM template to see the changes we made for our stream processing function. So I'm gonna minimize our previous function. So we have this new stream processor function that's processing our DynamoDB streams, right, and acting on those batches of records. A lot of the configuration for this is gonna look very similar, right? It's of type AWS serverless function. We specify the code URI, the handler, the runtime, all that stuff. The big difference is going to be in the event we have hooked up, right? All of our previous events have been API gateway events where we hook that up. We want to have HTTP endpoints for our Lambda function. That's the event that's triggering it. But this one, we're processing a DynamoDB stream, right? So the event here is of type DynamoDB. We're saying, hey, we want to hook up to this DynamoDB stream. We're not specifying a path and a method for HTTP, but we're actually specifying DynamoDB properties. So the stream ARN, we can use that get at function again, and a little bit about batch size, different configuration options there. But just showing you here, you can hook up different type of events to your different Lambda functions using this same sort of resource.
Alex, I think that batch size option is kind of interesting here, right? Because we're not necessarily updating that record for every single time one of the counters is updated. We're able to kind of aggregate that and increment a little less frequently. So it's asynchronous. It's never going to be exactly perfect, but it's good enough, and it scales a lot better this way.
Yep. Yeah, that's a great point, because if you have 100 different tag visits, concurrently, you have a pretty popular website, a lot of people coming in, you don't have to do 100 separate updates to that counter. You can batch them all together and just increment it once. Yeah, great point.
Yeah.
So when you're doing stream processing with Dynamo, that batch size can really help you to reduce some of the work there. Cool. So let's go back to our thing. We've now implemented this and deploy it. Let's go to tag/MBA, right? So let's record a few visits for the MBA, maybe 2 of these, 3 of these. Okay, we can check the count for the tag MBA here. You can see the tag MBA has 3 total visits. We also have 3 visits across all pages. The one thing I want to call out here is when you enable DynamoDB Streams, it only enables it from that point on. It doesn't sort of have all your previous write operations there. So you want to make sure you enable it sort of early on and plan for some of these use cases. So if I go back to that technology use case and look at the count here, it looks kind of wonky because I'm like, hey, I've recorded 5 visits for technology, but we only have 3 across all the pages. And that's because I implemented my global counter later on. But if I get a few tag, if I update this a few times on technology, maybe a few times for AWS, I can see the counter. So AWS has 2 visits. We have 7 visits across all our pages. So this is going to keep incrementing up. We'll keep maintaining the individual tag operations there as well. But the big thing to note there is, streams are only going to start from when you actually enable them. It's not going to have all your prior history there. That completes the workshop. I know we had to speed through that, and I apologize. There's just a lot to cover there. Again, the big thing I would say is we have this recorded. If you want to go watch it again, you can also go through that workshop guide yourself, and it explains a lot of these key concepts the same way. So you can do that at your own pace. Feel free to reach out for any of us. The big thing you want to do also is delete your template at the end, which I believe is SAM delete. Yes. So make sure you delete your stuff just so your resources are all gone in the end. I'll stop screen sharing and get up here with Pete. But yeah, just make sure you clean that up so you're not keeping those resources around. Again, this should fit under the AWS free tier, so it's not going to cost you anything, but you do just want to clean that stuff up if you're not using it.
Another point to make is for those folks who are making use of the environments that we provided, the AWS accounts. Those are temporary, but they will hang around for a while, maybe another 10 hours or so. So feel free to make use of those if you want to go back through and kind of work through the workshop again at your own pace. Yeah,
absolutely. I see a few questions, so I just want to hit some of those up. So can you say something about debugging Lambda functions? Yeah, so that's a great one. a few different ways on debugging Lambda functions. There are some tools. I saw someone mention earlier that like with AWS SAM, it actually has a way to run your functions locally and actually emulate an API gateway. So you can do some of that stuff locally if you want to. Another thing you can do is deploy these up to the cloud. That's generally what I do. Is I do all cloud side development because it's just a better, a more higher fidelity environment there. So if you're going to do that, then you're going to need to look into CloudWatch logs. So all the output from your function code, whether that's printing something to the console with console log or printf or whatever you want to do, whether that's, hey, it threw a hard error and your application blew up, all that output is going to get aggregated in CloudWatch logs, and you can go debug it that way. Let me see. Uthman, how easy would it be to replace Node.js code with Python? Yeah, super easy if you know Python. Like I love Python. That was my first language, and that's what I used to do a lot of my serverless development in. A lot of these principles are going to be the exact same. I'd say a lot of time with Lambda, what you're doing is sort of gluing together different AWS services. So it's going to look similar. You're importing the AWS SDK. It's going to be called Bodo3 in Python rather than just the AWS SDK. But you'll do that. You'll create your client. You'll add your logic there. But the mechanics are going to be very similar in Python as in Node. Let's see, Merrick asked me about batch size 100. So on that stream, I set a batch size of 100, and what they're going to try and do generally is gather up 100 events from your DynamoDB stream before sending it to your Lambda function. That being said, they're not going to wait around forever. Imagine you get 10 requests on your page a day. They're not going to just wait 10 days until you have 100 events to invoke your function. There's sort of a balance there. I can't remember. And I think you can actually configure like what's the maximum amount of time to wait versus stream, the batch size and different things like that. But it's basically going to be a combination of batch size or stream. So batch size is like a maximum amount of records they'll give you in a batch, but it could be fewer as well. Jimmy B asked where the video will be available. So number one, we previously recorded this back in August or September of last year. So if you look in the GitHub repo, there's actually a link to that video there as well. I'm not sure how we're going to, Neely, maybe you would know better. Will we distribute these to the various user groups, or how will they get access to this particular video?
That's true. Once it's been done, I will share this with the UG group leaders.
Perfect. Sounds great. So yeah, that'll probably be a better one since it's more direct. There's a small change or two since the one back in August. So yeah, watch out for that one.
New and improved.
Yeah, exactly. All right, let's see some other questions. I'm happy to go as long as you want. So feel free to cut me off, Pete or Neely, if you got other things to do. But this is all great stuff. So let's see. Oliver asked about end-to-end testing. Yeah, absolutely. I would definitely recommend end-to-end testing. One thing you can do on this particular, you just need to think about the behavior that you want to have here, right? So in this case, you could deploy a stack to a staging environment. You could hit a few different tags, make HTTP requests to a few different tags, and then call one of those count pages and make sure, hey, it has the number of counts I expect. It has the number of total counts I would expect to have something right there. If you don't want to do like a full end-to-end integration test, you could also just do end-to-end tests. You could do like more narrow integration tests where you're just working with the DynamoDB logic. Sometimes I'll do some of that stuff as well. So yeah, there's lots of other good stuff out there, but I would, I definitely recommend having some end-to-end tests, especially in these serverless applications where your infrastructure is part of your application, right? Like think about how DynamoDB Streams is part of our application that we're counting on for our logic there. We need to make sure that's configured correctly and have confidence in that before we roll that out to prod. So that's something you want to be testing, likely via end-to-end testing. Let's see, Ismail, are there any security practices or principles to have in mind working with this stack? I would say the big thing that'll help you, is just thinking about least privilege within your Lambda function. So making sure when you're setting those policies for your Lambda function, you're narrowing down what they can actually do. You're not giving it too broad of permissions. That'll help you out. The great thing I love about Lambda functions is they get injected with temporary credentials. They're only going to work for a couple hours, so you get like automatic tempo or credential rotation for you. It's also pretty easy to scope down your permissions. So I think Lambda makes it easier to handle these security type things. Other than that, sanitize your inputs. Make sure you're checking, you're authorizing your requests, however that is, authenticating and authorizing that. So I would say a lot of those basic things. The other thing is just managing sort of deployment credentials, right? So we talked about credentials for your Lambda function and permissions that way. But when I'm running those deployments, when I'm running SAM deploy, it's creating a bunch of different stuff, and you want to make sure you lock down who has access to that stuff, what they're allowed to do. Ideally, your developers don't have access to deploy to prod. That goes through a CI/CD system, which has its own lockdown credentials and things like that. So think about some of that. We should put SQS as middleware between Lambda to eliminate a lot of events. So the question is about using SQS as middleware in your application. That can work. SQS, I'm a huge fan of SQS. It works really well in a few scenarios. One is when you have, serverless parts of your application and non-serverless parts of your application, maybe ones that don't scale as well. I've seen people that have, API gateway, they have Lambda, those will scale really well. And then they have a relational database, and that won't scale a spike up quite as well as something like Dynamo or a more serverless type application. So then they might buffer stuff in SQS to where they're at least ingesting the event, and then they can put it into the relational database if they need to. I mean, this assumes that you don't have sort of conditional checks or other transactional things you need to do there. So it needs to work for your situation, but that can work. So SQS can work as like a nice buffer to handle spikes in traffic. I also like stream mechanisms, whether that's DynamoDB Streams or Kinesis Streams, if you're doing large scale processing of a lot of events. That allows you to batch it up really nicely and still get some ordering there, which is nice. All right. Shoaib, sorry, I'm totally butchering that name. How do you compare serverless framework versus AWS SAM? I mean, this is a tough one for me. I used to work for the people at serverless.com and the serverless framework, so I do love it. I would say like serverless framework and SAM are very similar in a lot of ways. They have a lot of the same concepts and different things like that, and sometimes it's just a difference in style. Serverless framework has plugins, which are ways for you to extend the functionality of it and allows for some niceties there. But AWS SAM has a lot of really nice features as well around some of that stuff. So I would say they are more similar than they are different. And it's probably more fruitful to compare one of those two to something like CDK or Pulumi, which are like a different type of a different approach to managing your infrastructure as code, and those differences are going to be a lot greater than the ones between serverless framework and SAM. All right. Oliver, DLQs versus other recommendations for failing requests. So this is a deep question. So basically, how do I handle failing requests? It depends a lot on the type of failure, the type of event source you have. Is it coming from SQS initially? Is it coming from Kinesis or Dynamo? And maybe there's like a poison pill message that you can't process in some way. What do you do with that sort of thing? Is it an API request where you want to respond immediately that it failed? So it depends a lot on that stuff. I think DLQ is a pretty good option for SQS specifically, just because, hey, if there's a message you can't process for some reason, there's no reason to keep trying and just leave it in your queue. And so I'll have a DLQ, and then I'll monitor that DLQ. I'll have like tougher monitors on the DLQ than I will on my regular queue, because your regular queue, maybe it fails for some reason here and there, just temporary blips. But if you get something to the DLQ, that usually indicates, hey, I had some code error somewhere. I have an unprocessable message. I need to figure out what's going on there. So yeah, I like DLQs for that. Also for some streaming type stuff, if you want to not block your stream, you can shuffle stuff off to the queue with the caveat that you lose ordering now. All right. Yeah, how do you compare traditional microservice architectures with Lambda and event-driven architectures? I think a lot of the same principles still apply. Whatever within your microservice, make sure it's the same bounded context. You're not trying to share a bunch of data across those, especially doing a lot of synchronous requests across microservices. That's going to get you in trouble, whether that's Lambda or whether that's Kubernetes or whatever you're doing. So I think a lot of those same type of principles apply. I would say, with serverless, Lambda, different things like that, rely on these managed services as much as you can. It's kind of amazing how much less you can do, and you can really rely on these really great primitives that AWS is providing you, whether that's a blob storage with notifications like S3, whether that's SQS and sort of the managed queue or worker pool with Lambda around that, whether that's a stream with Kinesis. Like it's pretty amazing what you can get there. So lean into some of that stuff. Edwin, what's the simplest way to measure read and write units for our DynamoDB tables? Check out CloudWatch metrics still. You can check out that stuff and just see your historical usage. You can look at max, you can look at averages, different things like that. When it comes to people working with serverless applications, particularly, a lot of times I'll recommend on-demand mode just because often their usage is lower and a little spikier, and it's probably just not worth the time to really optimize your read capacity units. Where I'm sure Pete talks to a lot of customers that they have really huge usage and it's worth it to them to sort of optimize that usage well, and it makes a difference on their bill. But if your DynamoDB bill is less than $100 a month, you shouldn't be wasting an hour of your engineer's time on it. Like you're probably losing money doing that. So just set it to on-demand mode and go there.
Yeah, those are good points. I do want to say, just like when you're kind of developing your data model and kind of building out your application, one thing that you can do is there's the DynamoDB API support a parameter called return consumed capacity. So when you make that call, you can actually have it return exactly how many read and write units were consumed. It's a really nice tool to just kind of validate that you've created an efficient pattern, right? And from that, you can actually go from there and think about how many requests per second you think you're going to see with your application. You can do some pretty accurate cost estimation. So return consumed capacity is a really nice tool when you're in that stage.
Yeah, absolutely. I love that. I love that point you're making there, like about you can calculate this stuff out, like do the math if you're really worried about some of this stuff. It's so much easier to do with Dynamo than compared to a relational database where it's just like, well, I have no idea what sort of long-term impact this is going to have on my CPU or RAM or what my bottleneck is going to be in my application. Whereas with Dynamo, you can say, hey, I'm going to have, this is how big my items are, this is how many requests I'm expecting. What if I did 2x this or 50% more or whatever? How would that change things? And you can calculate that pretty well. Cool, let's keep on rolling. Any good pointers, resources for DynamoDB schema design? Yeah, the DynamoDB documentation has a lot of really good tips. Go check that out. We've also got a bunch of hands-on tutorials and guides. You can check those out. I've got my book, DynamoDB book, if you want to check that out. Like, there's just a lot more resources out there than there were 5 years ago. So definitely check out some of those DynamoDB data modeling things. Adrian, is it okay to share? This is a great question. Is it okay to share raw DynamoDB stream events with other microservices, or would you rather transform it into some domain event in a middleware Lambda? I don't know what Pete thinks. I like that sort of the latter approach where your service that actually was responsible for creating that record in Dynamo, you probably have a better understanding of what just happened there, and you can shape it into some domain event that makes more sense to microservice, other services, rather than sort of making every service understand the internals of your application and different things like that. So I would generally say put it into some sort of domain event there. that what you see usually, Pete?
I see both, but I think I tend to think about it the way you do, Alex.
Yeah, cool. Oliver, can you give us recommendations on step functions or alternatives? I have to say, if not used carefully, it can be expensive. So yeah, step functions, you know, I'd say that's like a serverless plus type of topic. It's a really cool service from AWS that gives you like managed state machines and with a lot of really nice stuff there. You know, didn't get the time to talk about that today, but check that out if you have like a pretty well-defined workflow of steps and it could fail at different points. You want to have retries, all that sort of stuff. You can implement that as in a more like infrastructure like way rather than managing all that logic in your application code and some of the complexities around that. So step functions, really good for that stuff. I would say it's probably for slightly higher value operations just because there is a higher cost than if you're just running it yourself in sort of Lambda compute or EC2 or containers, whatever. But I think a lot of that, like the history, the guarantees, the retries, some of that stuff it's offloading can really make sense for those. Not sure if I missed any. I might have missed some older ones. So if you have any other ones, happy to keep going. I also don't want to keep everyone forever. So there you go. Giselle's adding some good resources there. The DynamoDB documentation, that team has done a really good job on some of that stuff and illustrating the concepts. I think just, Dynamo is interesting because it's very different from relational databases. So it's got a learning curve for people to it. But I think it's much easier to learn than relational. It's just that you learned relational 10 years ago and you've used it for 10 years and now you're used to it. But if you learn 5 key concepts in Dynamo, you can really understand it, and it's very predictable in a way that a relational database is not unless you have some really, really deep knowledge there. Thanks, all. Glad this was useful to you. I know we had to speed through the workshop at the end, so I hope you do get some time, outside of this if you weren't able to keep up to go through it again. Look through that written stuff, look through the recording, reach out if you have any questions, but and then just leave us feedback on how we could make this better. Any other notes from you, Pete? I've just been sort of monopolizing here a little bit.
No, just thanks very much, Alex, and also thanks to the folks who joined to help out answering the questions. Really glad everybody could join us today. Really would be helpful to get that feedback. As Alex said, this is the first workshop that we've run quite this way, and so there's probably some things that we can improve. But I really appreciate you hanging around a little bit longer too, Alex. There was a lot of great questions there towards the end, and I think there's a ton of value in that discussion. So
yeah, absolutely, this is great, and it's definitely not as hard for me to hang around from 9:30 to 10 as it was for you and the rest of the West Coast people to get up at 6 and be here. So
I might be taking a nap a little later today. We'll see.
Good. So, all right, thanks everybody. Feel free to reach out, and otherwise, have a good one.
Thank you all. Bye-bye.
Thanks, everyone. Bye-bye.
Thank you.